Hi friends, welcome to Talent Sprint's Banker's Choice program. In this session, we are going to learn about coding and decoding, which has a weightage of about 3 to 8 marks in various competitive exams. Coding and decoding is all about sending some information in a coded form such that only the desired person can decode that information and understand what information has been sent. We can get various types of questions from coding and decoding as the logics of coding the information are infinite. So let us first discuss some very popular logics from this topic and then we shall move ahead with different examples. Let us now look at the various ways of coding the word bank. If you take the first example here, the word bank has been coded as $%. That means the complete word here is represented with the help of various symbols. Now the simple logic here is each letter is represented by a particular symbol and that has to be considered as the coded form for the given letter. For example, the letter B is taken as $, A is taken as hash, N is taken as $, and K is taken as percentage. So once we get to know the coded form of each of these letters, we can find out the code for any other given word. Let us now look at the second way of coding here. The word bank has been taken as CBOL, which means B is taken as C, A is taken as B, N is taken as O, and the letter K is taken as L. The logic behind this kind of coding is shifting of the letters either in the forward direction or in the backward direction. If you observe here, each letter in the word bank has been shifted by one position in the forward direction. For example, the letter which comes after B is C. The letter which comes after A is B. After N, O. After K, we have L in the alphabetical order. So that is how each letter has been shifted by one position as per the alphabetical order. So we can say that the coded form of the word bank here is +1. That is the logic behind this coding is +1. So each letter has to be shifted by one position in the forward direction. Similarly, each letter can be shifted by 2 positions or 3 positions for that matter. Let us now take the third one. Here the word bank has been taken as AZMJ. That means the letter B becomes A becomes Z, N becomes M, and K becomes J. Now the third coded form here is similar to the second one, but the only difference here is shifting has been done in the backward direction. For example, as per the alphabetical order, the letter which comes before B is A. If you go in the cyclic manner, the letter which comes before A is Z. The letter which comes before N is M, and the letter which comes before K is J. So as per the alphabetical order, each letter here has been shifted by one position in the backward direction. So I can say that the logic in this coding is -1. That is shifting each letter by one position in the backward direction. Similarly, the letters can be shifted by 2 positions or 3 positions in the backward direction. Now the next one here is ABML. The word bank is taken as ABML. That is B is equal to A is equal to B, N is equal to M, and K is equal to L. Even in this form of coding, the letters have been shifted, but some of them have been taken in the forward direction and the others have been taken in the backward direction. If we observe, B is taken as A. That means it is shifted by one position in the backward direction. The letter which comes before B is A. If you go to the second position, the letter which comes after A is B. That means the second letter has been shifted in the forward direction. Again, the third letter N has been shifted in the backward direction because the letter which comes before N is M. And moving on to the fourth letter, K has been taken as L. That means it has been shifted in the forward direction. So we can understand that the letters of the word bank have been shifted here but in alternate ways. That means the first letter is shifted in backward direction, second in the forward direction, third in the backward direction, and again fourth in the forward direction. So we can say that this type of coding is in the alternate shifting form. So first letter is taken in backward, second one in forward, third one in backward, and fourth one again in the forward direction. So we can take it as -1, +1, -1, +1, and so on. Similarly, the other way of coding in this form could be +2, -2, +2, -2, or plus 3, minus 3, plus 3, minus 3, and so on. So we need to identify the logic based on the shifting of these letters either in the forward direction or in the backward direction. Now moving on to the next one here, the word bank has been taken as CCQO. Again in this case as well, the letters of the word bank have been changed to some other letters in the alphabetical order. Now the logic here can be understood by finding out the shift of each letter in the coded form. For example, the letter B is taken as C. That means it has been shifted by one position in the forward direction. So we can say that this is plus 1. If we move to the second letter A, it has been taken as C in the coded form. And the distance between A and C is 2. That means the letter A is shifted by 2 positions in the forward direction. So we can say that the C here in the coded form is 2 places away from A. Moving on to the third letter N, it has been taken as Q. And if you go by the alphabetical order, Q comes 3 places after N. That is N, O, P, Q. So we can say that Q is a result of shifting N by 3 positions in the forward direction. Similarly, the letter K has been taken as O. And if you try to find out the distance between K and O, it comes out to be 4 positions. That is K, L, M, N, O. So it is very clear that K has been shifted by 4 positions in the forward direction. So the letter O is a result of shifting K by 4 positions. So if you observe here, the pattern is plus 1, plus 2, plus 3 and plus 4. That means each letter here has been shifted by some positions in an increasing order. So friends, if you try to observe, the word bank has been coded in various ways in these 4 models. And the logic behind this coding is only the shifting of letters in different patterns. For example, in the first one, each letter was shifted by 1 position in the forward direction. In this one, each letter was shifted by 1 position in the backward direction. In the third case, they were shifted in an alternate manner. That means the first letter, third letter and fifth letter were shifted in backward direction, and the second, fourth and so on were shifted in the forward direction. And if we take the last one, there is a pattern in the shifting of the letters. That is, it is an increasing pattern, plus 1, plus 2, plus 3, plus 4 and so on. So this is how we are supposed to understand the logic behind the coding of the given word. Friends, remember that these are only some of the ways of coding the word bank. As I've already mentioned, there are infinite ways of coding a particular word. It is all based on the perception. So we just need to identify how the letters have been shifted by trying out the various things. There is no particular formula or method to find out the exact coding. It is all based on trial and error. So we simply need to check in different ways and identify the correct logic. Let us now look at some other ways of coding the word bank. Now if we take the first case here, the word bank has been taken as 211, 411. The logic in the first type of coding here is based on the positions of these letters as per the alphabetical order. If we try to assign each of the letters of the English alphabet with their positions in the alphabetical order, we can understand that the letter A is going to take the first position, B will be in the second position, C takes the third position and so on, and finally Z will become the 26th letter. So the logic behind this coding is based on that kind of positioning. For example, we know that B is the second letter of the English alphabet. So that is how we have got 2 in the first place. A is the first letter of the alphabet. So the one which is there in the coded form is the result of the position of A. The letter N will be 14th letter of the English alphabet. So that is how we have got the next number 14 here. And finally the letter K is the 11th letter of the alphabet. So that is how we have got 11 in the last position. So we can say that the word bank can be taken as 211, 411, where 2 corresponds to the position of B, 1 corresponds to the position of A, 14 corresponds to the position of N, and 11 is the position of K in the English alphabet. So to understand these kind of logics, it is very important that we remember the position of all the letters as per the English alphabet. And to do that, you simply write down all the letters and their positions and try to mug it up. Let us now understand the coding behind the second one. Here the word bank has been taken as 25261316. Now, what could be the reason behind this kind of coding? The logic is, here the positions have been taken in the reverse alphabetical order. For example, as already discussed, when we write A to Z in the alphabetical order, A becomes the first letter, B is the second letter, C is the third letter, and so on till Z is the 26th letter. But if we take the positions in the reverse order, Z is the first letter, Y is second letter, X is the third letter, and so on till A becomes the 26th letter. So here the coding has been done based on the positions of these letters in the reverse alphabetical order. So if we try to write down the positions in reverse order, we come to know that B will be the 25th letter. So that is how we have got 25 in the coded form. A is going to be the 26th letter, as it is the last letter in the reverse order. N will be the 13th letter, and K is going to be the 16th letter in the reverse order. So the other way of coding the word bank here is taking the positions in the reverse order. Now these two models are quite opposite to each other, because in the first case we have taken the positions in the alphabetical order, and in the second case we have taken the positions of the letters in the reverse alphabetical order. So it is very important that we remember the positions of the letters as per the alphabetical order. Let me now explain one simple way of remembering the positions of the letters in the reverse alphabetical order. Assuming that we know all the positions as per the alphabetical order, the positions in the reverse order can be simply understood by a simple formula. In ranking, we have learned that whenever we know the position of one of the persons from one end, we can find out the position from the other end by a simple formula. That formula is total number of persons minus the position from one end plus 1. That means if you know the position from one end, the position from the other end can be taken as total number of persons minus position from the given end plus 1. So with the help of this formula, we can always find out the position of the letters in the reverse order. Assuming that you know the positions of the letters in the alphabetical order, let us see how can this formula give us the positions in the reverse alphabetical order. For example, let us start with the letter A. We know that A is the first letter in the alphabetical order. So in the reverse alphabetical order, its position can be taken as T minus P plus 1, where T is total number of letters, that is 26, minus P. P is the position in the alphabetical order, that is 1 plus 1, and this is equal to 26. So we can say that the position of A in the reverse order, let us take it as A dash, is going to be 26. Similarly, if we move on to B, the position of B will be equal to total letters, that is 26, minus the position in the forward direction, which is 2 plus 1, and this comes out to be 25. Let us take the letter O. The position of O in the reverse order can be taken as total letters 26 minus, we have to remember the position in the forward direction, and the position of O in the forward direction is 15 plus 1. So the position of O can be taken as 26 minus 15, that is 11 plus 1, 12. So O will be 12th letter in the reverse alphabetical order. Let us take another example, the position of R in the reverse direction. So it can be taken as 26 minus, the letter R is 18th in the alphabetical order, plus 1. So 26 minus 18 is 8, plus 1 gives you 9. So we can say that the position of R in the reverse order is 9. So that's how it is very easy to find out the position in the reverse order once we know the positions of the letters in the alphabetical order. So if you look at the word bank here, we already know that B is 25 and A is 26. Now the letter N is 14th in the alphabetical order. So in the reverse order, it is going to be 26 minus 14 plus 1, and that will be equal to 13. So its position in the reverse order will be 26 minus 11 plus 1, and that is going to be 16. So that's how we can very easily find out the positions of the given word in the reverse order. And it is very easy to understand this once we know the positions as per the correct alphabetical order. Let us now take the next one. Here the word bank has been taken as YZMP. Now the logic in this type of coding is as follows. We know that the letter B is second in the alphabetical order. But when we come from the reverse side, that is in the reverse alphabetical order, the same second position will be occupied by the letter Y. So that is why B has been replaced with the letter Y. So B is second letter in the alphabetical order and Y is second letter in the reverse alphabetical order. Similarly, A is first letter in the alphabetical order, and when we come from the reverse side, Z is going to be the first letter in the reverse alphabetical order. And moving on to N is 14th in alphabetical order, and the 14th letter in the reverse alphabetical order will be M. And similarly, K is 11th letter in the alphabetical order. So from the reverse side, P is going to take the 11th position. So that's how we get the coded form of bank as YZMP, by taking the letters of same positions from the reverse side. So we can say that the logic here is the letters from reverse direction. Before we move to the next model, let us understand how to find out the letter which comes in position of these letters from the reverse side. Let's take the letter N. We know that in the alphabetical order, N takes 14th position. Now to find out what letter is going to come in 14th place from the reverse alphabetical order, what we can do is, first of all, find out the position of N from the reverse side. And that can be done with the help of this formula, as we have already discussed. So we can say that the position of N in the reverse side will be 26 minus 14 plus 1. That is total number of letters minus position in the alphabetical order plus 1, which comes out to be 13. So we can say that N from the reverse side is going to be 13th letter. Now to find out the letter which comes in place of N in the reverse direction, we can simply take the 13th letter which comes from the alphabetical order, that is in the forward direction. And we know that the 13th letter from the forward direction is M. The letter N here is replaced with M. Let us do the same thing for the letter K. We know that K is 11th letter in the alphabetical order. So from the reverse alphabetical order, the position of K will be 26 minus 11 plus 1. And that comes out to be 16. So we can say that the letter which comes in place of K from the reverse alphabetical order will be nothing but the 16th letter in the alphabetical order. And we know that the 16th letter in the alphabetical order is P. So that's how the letter K here is replaced with P. So from these two examples, you can understand that it is easy to find out the position in the reverse direction as well as the letter which comes in the same position in the reverse direction, if and only if we are perfect with the positions in the alphabetical order. So the immediate thing which you all need to do here is write down all the letters and mug up the positions of these letters as per the alphabetical order. And with the help of this formula, we can find out the reverse positions and the letters which come in the reverse position. Let us now take the next one. Here the word bank has been coded as 28. That means the 4-lettered word bank has now become a 2-digit number 28. The logic in this coding is the sum of the positions of the given letters. We know that B is second letter in the alphabetical order. A is first letter in the alphabetical order, N is 14th letter and K is the 11th letter. If we add up all these positions, we come up with the result 28. 2 plus 1 is 3, plus 14 is 17, plus 11 is 28. And that's how the word bank has been coded in this case. That is simply the sum of the positions of these letters in the alphabetical order. So here the logic is sum of the positions. Let us now take the next one. Here the word bank has been coded as 308. That means the 4-lettered word now has become a 3-digit number, that is 308. The logic in this coding is the product of the positions of the letters of the word bank. So instead of taking sum of the positions, when we multiply all these positions, we come up with 308. That is 2 into 1 into 14 into 11. That is equal to 308. So that's how we have got the coded form 308 for the word bank. So here we can say that the logic is product of the positions. And let us now look at the last case here. In this case, the word bank has been coded as a single digit number 7. The logic in this coding is the average of the positions of the letters of the word bank. We know that average is nothing but sum of all the elements by the number of elements. We have already found the sum of the positions of the letters of the word bank, that is 28. Now when we take the average of these positions, it will be equal to 28 by 4, as there are 4 letters in the given word, and that is equal to 7. So that's how we have obtained the coded form 7 for the word bank. So we can say that the logic here is average of the positions. So if you observe, in the last 3 models, we have performed some or the other arithmetic operation on the positions of the letters B, A and K. In the first case, it is sum of the positions. In the second case, it is a product of the positions. And in the third case, it is average of the positions. If you observe, all the coded forms on the right hand side are only based on the positions of the letters B, A and K. In the first case, it is the positions in the alphabetical order. In the second case, it is the positions in the reverse alphabetical order. In the third case, the letters have been replaced with those letters which come in the same position in the reverse alphabetical order. Next one is sum of the positions. This is the product of the positions, and the last one here is the average of the positions. So from this, it is very clear that we should be perfect with the positions of all the letters so that we can crack these kind of logics. Let us now take some examples based on the various logics that we have discussed just now. Let us now take an example from the various models of coding that we have just discussed. The question here is, in a certain code, the word board is written as CNBQE. So how will crime be written in that code? So the question says the word board is taken as CNBQE, and we need to find out the code for crime. As I've already mentioned, there are infinite ways of coding a particular word, and it is completely based on perception. So what we need to do here is just try out with different cases and find out what is the logic behind this coding. Now if you look at the word board here, the letter B is taken as C, and if you go by alphabetical order, we can understand that this is shifting by one place in the forward direction. If we take the second letter O, it has been taken as N, and as per the alphabetical order, this is one letter before O, so it can be taken as -1. The third letter A is taken as B, and this is nothing but one shifting in the forward direction, so that is nothing but +1. And moving on to R is taken as Q, that is again shifting by one position in the backward direction, as the letter which comes before R in the alphabetical order is Q, and the last one, that is D, is taken as E. So D has been shifted by one position in the forward direction as per the alphabetical order. So very clearly the logic behind this coding is +1, -1, +1, -1 and +1, that is shifting in alternate manner, +1 and -1. Now we need to find out the code for the word crime based on the same logic. So as we know that the first letter is shifted by one position in the forward direction, let us shift C by one position in the forward direction. So C becomes D, as the letter which comes after C is D. The second letter R should be shifted by one position in the backward direction. So the letter which comes before R is Q. So next position will be Q. The third letter should again be shifted in the forward direction. So I is followed by J. So J comes in the third position. Fourth letter should be taken in the backward direction. So the letter which comes before M is L in the alphabetical order. And finally, the last letter again should be shifted in the forward direction. So E should be taken as F in the coded form. So that's how we get the code for crime, that is DQJLF. So this is how we need to find out what can be the possible logic in the given coded form and apply the same thing on the given word to get the answer. Let us now take a second example based on the various coded forms that we have discussed earlier. Here the question is, in a certain code, knife is written as $3 $5 and lake is written as 7 at the rate $5. So how is fail written in that code? So as you can see, the coded form of two words have been given and we need to find out the code for the third word. Now, the word knife is taken as $3 $5 and the word lake is coded as 7 at the rate $5. Now here there is no logic behind the coded form. It is simply the replacement of each letter with either a symbol or a number in the coded form. For example, the letter K is taken as $. Even in the second word, the third letter K is taken as $. In the coded side. The letter N is taken as the number 3. I is taken as percentage, F is taken as hash, and the letter E, which is present in both the words, is taken as the number 5. So simply we need to find out the code for each of the letters and find out the coded form for the word fail. So we can say that the letter fail can be coded as follows. The first letter F is present in the word knife at the 4th position, and in the coded form the 4th position is occupied by the symbol hash. So F can be taken as hash. A is the second letter in the word lake, and on the coded side A is taken as at the rate. So we can say that A should be replaced with at the rate. I can be seen in the word knife and it is in the 3rd position, and the 3rd position on the other side is taken by percentage. So we can say that I should be taken as percentage. And the last letter L in the word fail can be seen in the word lake, that is the first letter, and here the first position is 7. So fail is coded as hash at the rate %7. So this is how you can solve this question simply by finding out the coded form of each of the letters from the given words. Let us now take the third example based on model 1. In a certain code, cat is written as 3120. Dog is written as 4157. So what will be the decoded form of 25144? As you can see here, the coded form for two words has been given and the decoded form for a third code is asked. So the word cat is taken as 3120. Dog is taken as 4157. And we need to find out the decoded form of 25144. If you try to understand the coded form, here the logic is nothing but the positions of the letters of the given words. As we know that C is the third letter, A is the first letter, and T is the 20th letter in the alphabetical order, the code for cat will be 3120. In case of dog, we know that D is 4th letter, O is the 15th letter, and G is the 7th letter in the alphabetical order. So that's how we get the code for dog as 4157. And now we are supposed to find out the decoded form for 25144. To find out the answer for this question, we need to replace the positions in the decoded form with the letters in the English alphabet. Let's try to do that. 2 can be taken as B, 5 is nothing but E, 1 is A, and 4 is D, and next 4 is again D. So this can be the decoded form for 25144. But if we take this 25 as 25, it becomes Y, as 25th letter is Y, 1 is A, and fourth letter is D, and again we have D. Otherwise, this 25 can be taken as 25, that is Y again. But instead of taking 1 and 4 separately, we can take it as the 14th letter, which is nothing but N, and the last 4 can be taken as B. And so on, we may also get various other answers. So the problem here is, we have no idea whether this number 25 is 25 or 2 and 5 separately, whether 1 4 is 14 or 1 and 4 separately. So that is the reason we are getting various answers for the decoded form of the given number, and hence we can say that the answer cannot be determined. So from this question we can understand that the codes which are based on the positions of the letters in the alphabetical order as well as reverse alphabetical order, there the decoded form can never be determined. Hence the answer for these type of questions should always be cannot be determined. Let us now take one last example based on the various types of coded forms that we have discussed in the beginning of the session. Here the question is, in a certain code, mobile is written as 56. How will the word phone be written in that code? So he has given the code for the word mobile, that is 56, and we are supposed to find out the code for the word phone. So the word mobile is taken as 56, and we are supposed to get the code for phone. Remember friends, whenever we have a 2 or 3 digit number as the coded form for the given word, the probable logic could be sum of the positions or the product or the average of the positions. So we can check with those logics and find out what can be the correct one. So let us first identify the position of the letters of the given word. As we know that M is the 13th letter, O is 15th letter, B is the second letter, I is 9th letter, L is 12th letter, and E is the 5th letter as per the alphabetical order. Let us just check with the sum of these positions. If the sum comes out to be 56, then the logic is very clear. If it is not 56, then we need to go with something else. So by adding these positions, that is 13 plus 15 is 28, plus 2 is 30, plus 9, 39, plus 12, 51, and plus 5 is equal to 56. So we are now able to say that the logic here is nothing but sum of the positions. So same thing needs to be done for the word phone to get the answer. So as I told you, you need to remember the position of all these letters. P is the 16th letter, H is 8th letter, O is 15th, N is 14th, and E is the 5th letter. So let us now add the positions here. 16 plus 8 is 24, plus 15 is 39, plus 14 is 53, and plus 5 will be equal to 58. So we can say that the code for the word phone should be 58. Let us now discuss the second model from coding and decoding, which is based on the shuffling of the letters from the given word. The question is, in a certain code, bean is written as A, B, and E, and sale is written as L, S, E, A. So how will news be written in that code? So if you can see here, the word bean has been coded as A, B, N, E, and the word sale has been coded as L, S, E, A, and we are supposed to find out the coded form of news. If you try to observe, the letters on both the sides are same. Here we have B, E, A, N, here as well we have the same letters B, E, A, N, but they have been jumbled. Similarly, in the second case as well, the letters S, A, L, E have been jumbled on the other side. So the simple logic here is find out the order of jumbling, and same thing can be applied for news to get the answer. Let's give the positions to each of these letters as per the word. B is the first letter, E is the second letter, A is the third letter, and N is the fourth letter. If you observe the coded form, the third letter has been brought to the first place, first letter has come to the second place, fourth letter here is come to the next place, and the second letter comes at the end. Similarly, if we take these letters as 1, 2, 3, 4, L is nothing but the third letter, S is the first letter in the word, E is the fourth letter, and A is the second letter. So very clearly from these two codes we can understand that the order of jumbling is 3, 1, 4, 2. 3, 1, 4, 2. That means we just need to give 1, 2, 3, 4 as the positions to these four letters and take the positions 3, 1, 4, 2 on the other side. So the first letter is N, second letter is E, third letter is W, and the fourth letter is S. And as we know that the order should be 3, 1, 4, 2. The third letter here is W, first letter is N, fourth letter is S, and the second letter is E. So the answer should be WNSE. So remember friends, whenever the same letters are present in the coded form, the probable logic could be jumbling of those letters. So just try to check if that satisfies, you get the answer, otherwise you need to go for some other logic. Let us now take a second example from model 2, which is again based on jumbling of the letters of the given word. The question here is, in a certain code, talent is written as AELNTT. How will the word sprint be written in that code? So the word talent is written as AELNTT, and we are supposed to find out the code for the word sprint. If you observe here, the same letters are present in the coded form of the word talent. So maybe the probable logic here is jumbling of the letters in a certain order. So let us try to work out and see what the order could be. So let us say that this is the first letter, second, third, fourth, fifth, and sixth letter in the given word. Now if you try to find the order in the coded form, we find that A, that is the second letter, has come to the first place, E is the fourth letter, L is the third letter, N is the fifth letter. Now when it comes to the letter T, we have no clue whether the first T or the sixth T has been brought to this place. Similarly, if you take the second T here, we have no idea whether it is the first T or the second T. So there are two possible answers here, either it is 1, 6 or 6, 1. But then when the logic is not certain, we cannot find out the answer for the given word sprint. So this shows that the logic which we are trying to apply, that is jumbling of the letters, is not working out. So we are wrong. So that's how sometimes we may not be able to get the answer in the first attempt. So let us try to now understand what can be the logic in this coding. The idea here is letters are all same, but if you observe, they have been simply arranged in the alphabetical order. That is, A is the first letter, E is the next letter in alphabetical order, L is the next one, N, and then followed by T and T. So simply all the letters in the given word have been arranged in alphabetical order to get the coded form. In that case, whether this is first T or sixth T doesn't matter. Why? Because we are simply arranging them in the alphabetical order. Now let us do the same thing for the word sprint. So arranging these letters in alphabetical order, the first letter would be I, followed by N, followed by P, followed by R, S, and T. So we can say that the coded form of the word sprint would be INPRST. So as you can see here, sometimes what we think may not work out. So simply try to do something else. Let us now discuss the third model from coding and decoding. In the previous models, we have observed that to get the coded form, any one of the operations was performed on the given word. But in this model, 2 to 3 operations are performed at the same time to get the coded form. Let's look at the question here. In a certain code, jealous is written as BFKKTVP. How will hearten be written in that code? So the question here is the word jealous, that is JEALOUS, is written as BFKKTVP. As I've already mentioned, here the coded form has been obtained by performing 2-3 different steps on the given word jealous. The first step is to divide the given word into different parts. That is, the first 3 letters JEA is the first part, then L is taken as the second part, and the last 3 words OUS is the third part. Now, the second step is to reverse the set of letters in each of these parts. So, JEA becomes AEJ, L remains L as it is, and OUS becomes SUO. And now, the third step is to shift the letters in each of these sets either in the forward or in the backward direction. So, if you can observe from the given code, the letters in the set AEJ have been shifted by 1 position in the forward direction, L has been shifted by 1 position in the backward direction, and SUO is again shifted by 1 position in the forward direction. So, A plus 1 gives B, E plus 1 is F, J plus 1 is K. L minus 1, that is L is replaced with the letter which comes before L, that is K again. S plus 1, so S is replaced with the letter which comes after S, that is T. U plus 1 gives V, and O plus 1 gives P. So that is how we obtain the code for the given word jealous. Let me repeat, the first step is to divide the given word into different parts, that is JEA, L and OUS. The second step is to reverse the letters in each of these parts. So JEA becomes AEJ, L remains as it is, and OUS becomes SUO. And the third and final step is to shift the letters in each of these parts. Let us do the same 3 operations on the word hearten to get the answer. So the given word is HEARTEN. Now we know that the first step is to divide the word into 3 different parts, that is the first 3 letters, then the 4th letter and the last 3 letters. The second step would be to interchange or reverse the letters in each of these parts. So HEA becomes AEH, R remains R as it is, and TEN becomes NET. And the final step is to shift the letters in the first part by 1 position in the forward direction, the second part is 1 position in the reverse direction, and the third part by again 1 position in the forward direction. So here the coded form for the word hearten would be A plus 1, that is B, E plus 1 F, H plus 1 will give I, R minus 1 would be Q, N plus 1 is O, E plus 1 F, and T plus 1 will be U. Therefore, the coded form for the word hearten as per the given code would be BFIQOFU. So friends, as you can see in this model, in certain questions 2-3 operations are performed on the word to get its code. So to answer these type of questions, we need to first group the word into different parts, then interchange or reverse the letters in each of the parts, and finally do some shifting either in the forward direction or in the reverse direction to get the coded form. Let us now discuss the 4th model from Coding and Decoding, which is a very simple question. This question can actually be answered within no time. Let's take an example. The question here is, in a certain code, green is blue, blue is yellow, yellow is red, red is black, black is white, and white is brown. What is the color of blood according to the given code? Now, as you can see, this is really a sitter and can be answered within no time. We know that the color of blood is red, but as per the given code, red is not red, it is black. So the answer for this question should be the color of blood will be black. Though it is a very simple question, let me draw your attention to one point here. Some students in a hurry mark the answer for this question as brown. Now the thinking goes in this manner. They say the color of blood is red, but red is not red, it is black. Black is not black, it's white, and white is not white, it's brown. So finally they come up with the answer as the color of blood is brown, which is a wrong way of answering the question. For these type of questions, we should only look at the required color and its code. We should not continue with the next code again. So the simple answer here is the color of blood should be black. Let us now discuss the fifth model from Coding and Decoding, which is a 5 marks question in bank exams. Let us look at the question here. In a certain code, for profit order now is written as ho ja ye ga. Right now for him is written as ga ve ja se. Place order for profit is written as ga bi ho ye. Only in right order is written as vi du ye zo. So as you can see, 4 different statements are given and 4 different codes for each of the statements is given on the other side. We need to identify the code for each of these words and then answer the 5 questions followed by this. The most important point to be noted here is the codes which appear on the right hand side are not in the proper order. That means we cannot say that the code for is ho or the code for profit is ja, or similarly the code for place is ga. That would not give the correct answer as the codes on the right hand side are jumbled. So one thing which we can understand here is the code for or profit or order or now should be any one of these 4 things on the right hand side. Now to identify the exact code for the given words, we need to find out those words which are common in more than 2 or 3 statements. So let us first try to find out any word which appears here in 3 or 4 statements. If we observe, there is no particular word which comes in all the 4 statements. So let us find out those words which are there in any of these 3 statements. Now, if you look at the first, second and third statements here, the word for is there in all these statements. So it is very clear that the code for should also be there in these 3 statements here. So let us now find out what is common in 3 statements on the right hand side. So if you observe, the 2-lettered word which is common on the right hand side is ga, ga. So very clearly I can say that the code for should be ga, ga, as there is no other word which is common in these 3 statements and there is nothing which is common in these 3 statements on the other side. So now I know that the code for should be ga, and let us cancel the words on the other sides. Now let us find out something else which is common in 3 statements. So if you look at the statements here, the word order is there in statement 1, statement 3 and statement 4. So it is obvious that the code for order should be present in statement 1, statement 3 and statement 4 on the right hand side. So let us find out the code for order. Now the one thing which is common in statement 1, 3 and 4 here is ye. So very clearly it is the code for order. So we can say that order is equal to ye. And let us now cancel the word order and its code to make the solution simple. Let us now find out any other word which is common in 3 statements. Now by observation we can say that there is nothing which is common in 3 statements. So now we can proceed for those words which appear in 2 statements. Now, from the first and the second statement, we find that the word now is common. So its code should be present in the first and second statement on the right hand side. So let us underline now and check the code for it on this side. And that should be the word JA, as it is the only word which appears in statement 1 and statement 2 on the right side. So now can be taken as JA. And let us now strike off the words JA from the coded side. Now if you look at statement 1, there is only one word profit which is left out, and on the right hand side the only word which is left out is ho. So it is clear that profit should be taken as ho. So we can say that profit is equal to ho. And similarly here the profit and ho here can be cancelled. Let us now check anything else which is common in two statements. As the first statement is already over, now let us concentrate on the second, third and fourth statements. Now from the second statement and the fourth statement, we find that the word right is common. So let us now find out the code for right on this side. So from the second and fourth statement here, the word which is common is VE, way. So clearly the code for right should be way. So just strike it off and take it on this side. That means right should be taken as VE. Now if you look at the statement 2, the only word which is left out here is him, and on the right hand side the only word left out is say. So clearly the code for him should be SEC. So let us take him as SEC, and that finishes the first two statements. Now moving on to the third statement, the only word which is left out here is place. So clearly the word BI should be the code for place. So BI can be taken as the code for place. So this finishes the first three statements. Now when we look at the last statement, there are two words left out, only and in. And here on the right hand side there are two codes left out, that is DU and ZO. As the word only is present only in the fourth statement and is not common with any other statements, we cannot find out what exactly is the code for only, as it can be DU or can be ZO. Similarly, when you look at the word in here, the word in is there only in statement 4. So again the code for in can be DU or ZO. So remember that after finding out all the possible codes, in any of the statements, if two or more than two words are left out, their independent codes cannot be determined. So here the code for only can be DU or ZO, and the code for in can be DU or ZO. So for these two words we can say that it should be DU or ZO. Therefore if only is DU, in should be taken as ZO. If only is ZO, in should be taken as DU. So with this we have finished finding out all the possible codes for the words given on the statements on the left hand side. Let us now see the various questions asked here. The first example is, what is the code for him? Now we know that the code for him is say. So that gives you the answer for the first question. The second question is, what does by stand for? Now as you can see, the word by is nothing but the code for the word place. So we can say that by stands for place. The third question is, what is the code for order? From this side we know that the code for order is YEA. So we can say that order is coded as A. So as you have seen here, answering the questions hardly takes any time. The only thing which needs to be performed is find out the codes for the given words on the left hand side. Let us now take the fourth example from model 5. Here the question is, for, way, do could be a code for which of the following options? So here we need to find out the decoded form for the given code. As we have already found all the possible codes from the given question, let us first find out what are the possible words for the given codes. From these statements we can find that the code VE is used for the word right. So very clearly VE means right. We know that the word DU could be a code for only or in, as in the last statement two words are left out and on the coded form two words are left out, DU and ZO. So we know that du can be a code for only, or it can be a code for in. So from this we can say that du means only or in. But the word for is not available in any of the codes here. Therefore, it is obvious that for cannot be any word which is given in these statements. Now let us see how to get the answer for this question. The answer here can be obtained simply by eliminating the wrong options. We very well know that the word right should definitely be present in the correct answer. So let us find out those options which does not contain the word right. As option number 1 has got right, it may be a probable answer, but option 2 is not having the word right. So this cannot be the correct answer, as the code VE stands for right. Similarly, option 3 cannot be the answer, as the word right is not present. Option 4, we find that the word right is there. So it may be a probable answer, but again option 5 cannot be the answer, as the word right is not present. So far we have eliminated 3 options, option 2, 3 and 5. And the correct answer has to be either option 1, that is in right spirits, or option 4, place in right. Now if you look at the word du, it is a coded word for only or in. So definitely the correct answer should either have only or the word in. Now if you look at option 1, the word in is present. So again this may be a possible answer. And when you look at option 4, the word in is present. So we cannot eliminate any of these 2 options. If you look at option 1, the other word which we have here is spirits. But spirits is not available in any of the statements given on the left hand side. And when you look at option 4, the left out word is place. And the code for place from these statements is BI. Therefore, we can say that place here is BI. But this word BI is not given in the question. So it is obvious that option 4 cannot be the answer. Why? Because had it been the correct answer, BI should be there in the given statement. So we can now eliminate option 4. So the only left out option is option 1, and that has to be the correct answer. And this can be justified because here we have a new word spirits which is not available in any of the statements on left hand side. And here we have a word for which is not available in any of the statements on right hand side. So that's why we have option 1 as the correct answer. Let us now take the last example from model 5. This example again is based on elimination of the wrong answers. Let us look at the question here. Which of the following may represent only for now? And 5 options have been given, and we need to find out the correct option out of the given 5 options. The given statement is only for now, and from this side we very well know that the code for now is JA. So very clearly the code for now is JA. The code for is GA. The code for is GA. And the code for only can either be DU or ZO. So very clearly the code for only can either be DU or ZO. After knowing the codes for all the words, it is very obvious that the correct answer option should have the codes GA and JA. So let us find out those options with the codes GA and JA. In option 1 we have JA, but GA is not available. So this cannot be the answer. In option 2 we have GA, but JA is not available. So this cannot be the answer. In option 3 we have GA as well as JA. So this may be the correct answer. So let us now look at the word ZO. We know that the code for only should either be DU or ZO. And in the given option it is ZO. So this can be taken as the correct answer, as the codes ZO, GA and JA are available here. So third option can be taken as the correct answer. And we need not verify the remaining 2 options. So friends, as we have seen here, answering the 5 questions is not a difficult job. The only thing which we need to do here is find out the codes for all the words on the left hand side. And that can be done simply by finding out those words which are common in all the 4 statements or 3 statements or 2 statements. Remember, always go for maximum number of statements to find out the common words. That is, first check for those words which are available in all the 4 statements, and then go for 3 statements, and then for 2 statements. And finally, we can check out the left out words. Let us now look at the 6th model from Coding and Decoding, where the code for the letters is given in terms of a symbol or a number, followed by a few conditions. So before we find out the coded form for the given questions, we need to check all the conditions and then get the answer. Let's look at the question here. Now, as we can see, for various letters, the codes have been given as shown in the table. For example, the letter M is to be coded as 8. J should be coded as 4, R should be coded as @ and so on. So we find here that for each of the letters given, the code is either in terms of a number or symbols like @ copyright, dollar and so on. And these codes are followed by certain conditions. The first condition is if both the first and the last letters are vowels. That means if both the first and the last letters are A, E, I, O or U, these are the 5 vowels, then their codes are to be interchanged. For example, let's assume in the given word the first letter is vowel as well as the last letter is also a vowel. So we need to interchange the codes for these 2 vowels, and the remaining letters are to be coded as given in the table. The second condition is if the first letter is consonant, that is anything other than vowel, and the last letter is vowel, then both are to be coded as the code for vowel. So for a given word, if we find that first letter is consonant and the last letter is vowel, then for both the letters we should take the code for the vowel only, and the remaining letters are coded as given in the table. And the third condition is if the first letter is vowel and the last letter is consonant, then both are to be coded as the code for consonant. So in a given word, if the first letter is vowel and the last letter is consonant, then for both these letters we have to take the code for consonant only, and the remaining letters are coded as given here. Let's look at some of the examples. The first question here is, what will be the code for AMZGUB? So this is the given word, that is AMZGUB. Now as you have seen, the conditions are based only on the first and the last letters. So let us identify the category of the first and the last letters and do the coding as given in the conditions. So here if you can see, the first letter is a vowel, that is A, and the last letter is a consonant, B. And the condition which is given for first letter vowel and the last letter consonant is the third condition. That is, if the first letter is vowel and the last letter is consonant, both are to be coded as the code for consonant. That means A and B both must be coded as the code for the consonant B only. So let us find out the code for the consonant B, that is nothing but 1. So we can say that A should be taken as 1. Though the code for A is 9, here we have to take it as 1 because the condition says when the first letter is vowel and the last letter is consonant, both are 1. For the remaining letters, we need to take the codes as given in the table. Now the code for letter M in the table is 8. So 1 is followed by 8. The code for letter Z is $. For G, it is percentage. For U, it is 7. And the code for B is 1. So this is the answer for the given word. Let us take the second question. What will be the code for the word GDWZMI? So here if you see, the first letter is G and the last letter is I. That is, the first letter is a consonant and the last letter is vowel. So let us now look at the condition which is given for first letter as consonant and the last letter as vowel. And that condition is nothing but the condition number 2, which says if the first letter is consonant and the last letter is vowel, both are to be coded as the code for vowel. That means here both the consonant and vowel must be coded as the code for I. The code for I is 5. So G can be taken as 5. Remaining letters as it is as given in the table. So D is coded as copyright, W is coded as 2, Z is coded as $, M is to be coded as 8, and again I should be coded as 5. So this is the answer for the word GDWZMI. So friends, as you can see here, finding out the answer is quite easy. But the only thing is we need to verify the conditions given in the question and accordingly get the code for the given words. Let us now take few more examples based on the same concept. The third example here is what will be the code for IBHJRE. Now as we know that the conditions are based on the first and the last letter of the given words, let us identify the category of the first and the last letters. Here the first letter is I and the last letter is E. That means both the first and last letters are vowels. And the condition which is to be followed for such a given word is the first one, which says if both the first and the last letters are vowels, their codes are to be interchanged. So here first and last letters are vowels, we need to interchange the codes for I and E, and the remaining letters are coded as given in the table. So to get the code for I, we should find out the code for E, and the code for E is hash. So I is to be coded as hash, B is coded as 1, H is to be coded as 6, J is coded as 4, R is coded as @ and the letter E is to be coded as the code for I because their codes have been interchanged. So E is to be coded as 5 because I is coded as 5. So that's how we get the answer for such a word where the first and last letters are vowels, simply by interchanging the codes for these two vowels. Let us now look at the fourth example. The question here is what will be the code for RPDAEK. Now here if you take the first and last letters, the first letter is R and the last letter is K, and both these letters are consonants. And now from the given conditions, there is no condition which mentions about both the first letter and the last letter as consonants. Therefore, there is no condition for this particular category where the first and the last letters are consonants. So here we should directly code the word by using the codes as given in the table without following any of the conditions. So the code for R is @, the code for P is 3, the code for D is copyright, the code for A is 9, for E it is hash, and the code for K is star. So that's how we get the answer for the example 4. So friends, remember that for these type of questions, always follow the conditions and then do the coding for the given word as per the codes given in the table. And if there is any word which doesn't come under any of the conditions, the coding can be done directly from the table. So friends, these are the various models which you can expect from the topic of coding and decoding in bank exams. But before we close the session, let me tell you, this is a topic which is completely based on the perception of the student. It's all about getting the right idea at the right time. And there is no guarantee that you will get the correct answer for the given questions, as the coding can be done in infinite ways. So remember, when we solve questions from coding and decoding in the exam, you should always take care of the time which you are spending on these questions. If within 30 or 45 seconds you are not able to get the logic for the given word, it is better that you leave the question and move to the next one. Because there is no point in wasting time on these topics where there is no exact method of getting the right answer. So solve these questions wisely or leave them if you are not able to get the logic in 30-45 seconds. See you in the next session. Thank you.